All right, so extreme value theorems are really on continuous functions on closed intervals. Rolle's theorem is the first one we're going to talk about. It says let f be continuous on the closed interval AB and differentiable on the open interval AB. If f of A equals f of B, then there is at least one number C in AB such that the derivative is 0. What are they saying? Well, if on a function you start and end at the same point, okay? Start and end at the same point. There has to be a point in between where you have a 0 slope. Even if you went straight across with a line, that whole line would have a 0 slope. Like you have to have a point. If they start and end at the same point, then there has to be somewhere in here where you're going to have a turn. It just is what it is, okay? Now, a couple things. It has to be continuous and differentiable. So like this guy is going to give you an undefined on your derivative here, so you can't really use this to prove it. You have to start out with your if then. If it is continuous and differentiable, all right, and you start and end at the same point, somewhere along the way you had to have a 0 slope. It's impossible, okay, to not have that. That is Rolle's theorem. So typically they'll say, first, can Rolle's theorem exist here? And if it does, tell me the points that actually prove it. And so that's where your examples are. It says find the two x-intercepts. What are x-intercepts? That's where your x's are, where your y's are 0, right? Where you cross the x-axis, x-intercept. Show that the derivative is 0 at some point between the two intercepts, okay? So what are they saying? They're saying, well, find where it crosses the x-axis. Those are your intercepts. Find where it crosses the x-axis. Those are the same value, y values, right? At your x-intercept, your y values are both 0. So that it has to be continuous. This is a continuous function. It's a parabola. It has to be differentiable on this interval, okay? And then if it is, and you have the same y values at those 2 points, somewhere along the way it had to turn, okay? So finding the x-intercepts. So find the x-intercepts means set it equal to 0. X-intercept is where y is 0. So we're going to set this guy equal to 0 and figure out where it crosses the x-axis. That's a really beautiful factoring, right? I mean, they could not be any nicer. My two intercepts are 2 and 1, okay? So easy intercepts. What that means is at 2, my y value is 0, and at 1, my y value is 0. So somewhere along the interval from 1 to 2, I have to, and by this I mean interval, not point, right? So somewhere on the interval from 1 to 2, I have to have a 0 slope because they're at the same point, y value. So either it went straight across and it's 0, all the slope all the way across, or it had to go down and turn and come back up to that point, or go up and turn and come back down to that point, because we know those 2 points have the same y value. They're both 0. All right. So where does that happen? Well, you can find out where that happens by going to your first derivative. If my f of x was x squared minus 3x plus 2, my derivative is going to be 2x minus 3. Where's my slope 0? Well, wherever that guy equals 0. Add 3, divide by 2. At x equals 3 halves, I have a 0 slope. Does 3 halves fall in this interval? Yes, because Rolle's theorem said it would. Okay, that's all Rolle's theorem is saying. If your y values are the same at your endpoints, then, and it's continuous in between, it didn't jump, then somewhere in between you have to have a 0 slope. It's impossible to not, okay? Find all the values of c in the interval -2, 2, such that the derivative of c equals 0. So this is continuous, right? It's a continuous function. You can see that. We want to find out if -2 and +2 give us the same y value, because Rolle's theorem does not apply if they don't, okay? So if they're asking you to do Rolle's theorem, then you really need to make sure that when you plug in your two x values, that you get the same y value, which, by the way, these are both even exponents, and it's just the positive and negative of the same number. So it is going to give us the same answer, but we will do this just to be nice. All right, so we have negative 2 to the fourth is what, 16? Minus negative 2 squared times 2, which is 8. So this is going to give us 8, y value of 8. When we plug in a positive 2, we get the same thing. So we know that somewhere in between, we're going to have something that meets this criteria at least once, all right? So now we need to figure out what it is. Well, to do that, we take first derivative. We are going to, where does this equal 0? What equals 0 at 0, negative 1, and positive 1? So we actually have 3 places that this guy gives us a turn, okay? They actually all fall in the interval. If they didn't, you would just list the ones that do based on the question. But you can see it does. From negative 2 to positive 2, at negative 1, at 0, and at 1, you're going to have a 0 slope. It is a turn in the graph. Okay, here's the thing about mean value theorem. So Rolle's theorem says that if you start in at the same point, then you have to turn somewhere. Mean value theorem says that if you have 2 endpoints and it's a continuous function, you can take the average of those, okay? So the average of the 2 endpoints is your mean value, right? Your average. And somewhere along that curve, you hit the exact point that you were at your average, okay? And we actually do a word problem with it. But like, if you're driving from here to Columbia and your average is 40 miles an hour, so if you take your entire mileage divided by your entire time and you got 40 miles an hour, at some point on your trip, you hit exactly 40 miles an hour. That's all the mean value theorem says. So the first thing you have to do is it has to be continuous, it has to be differentiable. You have to find your mean value, your average, and then find your first derivative and set it equal to your average and say, does that fall in my endpoints? So that's what mean value theorem says. And that's all the words for that right there. That's what all those words mean. So it says finding a tangent line. Given this function, find all the values of c in their intervals such that, and they give this function. All they're saying is find the average between your endpoints, okay? You'll notice that looks strangely like slope, doesn't it? y2 minus y1 over x2 minus x1, right? There we go. Find your average slope on this curve, and then your first derivative should equal that exact slope at some point in your interval, okay? So the first thing you have to do is find your average slope. It's your slope of your secant line, pretty much. The line, if you were to cut from your starting point to your ending point, okay? That slope is what you're trying to find first. So you're using your original function for that. Then you're going to take your derivative and set it equal to that slope of the secant line there. There will be a tangent that is parallel to it. So we're going to start by plugging in. So f of 4, that's my endpoint here, is going to be 5 minus 4 over 4, which is 5 minus 1, right? Which gives us what? 3, all right? That's my f of 4. F of 1 is going to be 5 minus 4 over 1, which gives us 1. So this is my y2 and y1, all right? So then I'm going to just find the slope of my secant line. This is y2, right? Because that's my x2. I just plugged it in. This is my y1. That's my x1, okay? y2 minus y1 over x2 minus x1. It helps do 5 minus 1 is 4. All right, so 4 minus 1, we get 3 over 3, which gives us 1. There we go, that's better. All right, so here's the thing. This is my slope of this line that cuts from my starting point to my ending point. That's my secant line, all right? That's the slope of it. It's 1, positive 1, all right? What the mean value theorem says is somewhere along this curve, you're going to have a slope of a tangent line that is exactly that same slope, okay? How do we find that? Well, slope of the tangent line is first derivative. So we need to figure out where the first derivative then, where does this equal that slope? So that's what we're going to do. Take our first derivative. So this is a little bit of a weird first derivative, right? We get, so if this guy is 5 minus 4 over x is 4 times x to the negative 1, right? Everybody agree with that? So that's going to be 5. So the 5 is going to go away, right? That's 0. Negative 1 times negative 4 is positive 4. Subtract 1, negative 2. That's the same thing as 4 over x squared. So that is my derivative. We want to know where that equals 1. Okay, thankfully it's 1 because you can just reciprocate, right? Reciprocate both sides. So the reciprocal of the left-hand side is x squared over 4. The reciprocal of 1 is just 1. Multiply both sides by 4. X squared equals 4. So x is going to equal either positive or negative 2. However, what interval am I looking at? From 1 to 4. Only one of those falls in it. So the only one that proves this theorem is at x equals 2. So at x equals 2, you will have a slope of 1. And if you plug it in, you see that 4 over 2 squared is 1. How do you see this? It says 2 stationary police cars are equipped with radar 5 miles apart. A truck passes the first patrol car. Its speed is clocked at 55 miles an hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles an hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some time during the 4 minutes. All right. So 4 minutes is 1/15 of an hour. 4 over 60 is 1/15, okay? So if I were to do this as sets of points, at 0, he was going 55 miles an hour. And at 1/15th, he was going 50 miles an hour. Everybody see? Time 0, he was going 55. Time 1/15th, he was going 50. All right, so if I apply my, subtraction here, And I will say they do absolute value because they're talking about speed and time, not direction. So if you subtract these two, you're going to get 5. If you subtract these two, you're going to get 1/15. We're doing absolute value because we're talking about time and speed. So it's okay. His average over that 4 minutes is going to be 75 miles an hour. Well, mean value theorem says that if his average was 75, at some point he had to hit 75. Mean value theorem proves it. Travel is continuous. Travel is continuous. And so even though both were clocked within the speed limit, he made it too quickly.